Tuesday. So what we're looking at today is the quadratic formula. The quadratic formula. Now what the quadratic formula is the last way that we can solve quadratic equations that will work every single time. So for any given quadratic, ax squared plus bx plus c, where a is not 0, we can use the equation x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a to find the solutions of the quadratic equation. And it will work every single time. Now there are ways that we can actually go and show how to get to this equation here, but it's really just using completing the square on the equation ax squared plus bx plus c. Now this formula here will work every single time no matter what the equation of the quadratic is. As long as we have a quadratic equation equal to 0, this here will work. Let's go on and use it here and see how this works. So we're starting off with the equation x squared plus 3x is equal to 5. Now for this to work, we need the equation, the quadratic equation, equal to what? 0. So to make it equal to 0, we can do what to both sides? Minus 5 from both sides. And when we subtract 5 from both sides, we're left with x squared plus 3x minus 5 is equal to 0. Any questions on this here so far? So here we'll go on and list out the values of a, b, and c so we can identify what they are. We won't really write them out for the rest of them, but I want to do this at least once so we can identify them. So what is the value of a? B is, and c is negative 5. Because it's coming from ax squared plus bx plus c. Any questions on this here so far? Now the quadratic formula is x is equal to b plus or minus the square root of b squared minus 4ac all over 2a. This is the formula for the quadratic equation. Well, let's plug in our values. X is equal to, well, we have negative b. What is the value of b? Plus or minus the square root of, well, we just said b is 3, so we'll have 3 squared minus 4. Well, what is a? And c is all over 2 times a. Well, a is still 1. So what have we done so far? We've just plugged in the values of a, b, and c, yes? Simplify. Well, the first thing we have is negative parentheses 3, close parentheses. Well, what would that be? Just negative 3, yes? Plus or minus. Now what we'll do next is we can do this by hand, but there's no reason to, is we want to simplify everything inside the radical first. So we still want the square root, we want to simplify what's inside. Because the graphing calculator will simplify radicals, but it won't simplify it in radical form, as it'll give us the decimal version of it if it doesn't come out evenly. But we can also have negative numbers in here, because our complex solutions are solutions where we had I as the answer, like we had yesterday, can also be a part of this, so that means there could be a negative inside the radical. Well, the TI-30XS will not simplify radicals with imaginary answers. The yellow calculators will simplify radicals into simplest radical form, so it won't turn it into a decimal, the one that we want, but it won't deal with I. The graphing calculator can deal with I, but it'll turn it into a decimal. So what we want to do is simplify everything inside the square root first. So we can type in the calculator, parentheses 3, close parentheses squared, minus 4 times 1 times negative 5, and hit enter. Can we get what? Just a little bit, I can't hear you. We get 29. Because 3 squared minus 4 times 1 times negative 5 is 29. Okay. And on the bottom, 2 times 1 is 2. Now at this point here, we could grab the yellow calculator or the TI-30XS and hit square root of 29, enter, and see if it does reduce. And it'll tell us that it's the square root of 29. It doesn't reduce any further than this here. Well, let's see if there's anything else we can do. Can I simplify negative 3 plus 29? Can I add those together? Is negative 3 and 29, are they like terms? What is 29? Well, the square root of 29 is a decimal, 5 point something is a decimal number. So if I really wanted to add or subtract these, well, I'd have to turn the square root of 29 into a decimal so that we could actually add or subtract. So in its current form, we can't combine these. That is it. That is the answer. Because that's as far as we can take it. There are no greatest common factors in the numerator and denominator. There's nothing we can reduce it down to. That's it. Any questions on this here? Let's look at the next one. 3x squared plus 4x equals 10. So if we want to solve this using the quadratic formula, we need this equal to what? 0. You're welcome. We need it equal to 0. So what can we do to get this equal to 0? Exactly. Which would give us 3x squared plus 4x minus 10 is equal to okay. Any questions on this so far? Well, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just start plugging our information in. So the first thing we have is negative b. Well, what's the value of b? Almost 4. Because again, we're still going off the equation ax squared plus bx plus c. Now we don't have to stick with x's. It's really the number that is squared, or the variable that is squared, not the number. Because if it's x squared, r squared, z squared, the letter in front of it, sorry, the number in front of it would be our value of a. Because if we had r squared, the number in front of r squared would be a. B is always going to be in front of the variable to the first power. So our b here is 4. So we plug it in for b. Plus or minus, here we're going to have 4 squared minus 4. Our value of a is, got it right the first time, 3. And c is negative 10. All over 2 times 3. A is always going to be the number in front of x squared. B is always going to be the number in front of x, and c is the number without a variable. A is in front of the variable that has the degree 2 or second power that is being squared. B is in front of the variable to the first power or has no exponent. And c is the one without a variable. Now again, at this point here, we just need to simplify down to get to our answer. Well, to start off with, we'll have -4 plus or minus the square root. So again, we want to simplify everything inside the radical first. So in the calculator, we would do parentheses 4 close parentheses squared minus 4 times 3 times -10. And if we did this here, we should get 136. Because 4 squared is 16. Minus, well, 4 times 3 is 12, times 10 would be 120, and it would be -120. Well, negative and negative make a positive, so 16 plus 120 should be 136. And 2 times 3 is. Any questions on this here? So what is the square root of 136? Because again, we don't want to just type the whole thing into the square root, because this number could have been -136 and the yellow calculator would have thrown up an error because it cannot take the square root of a negative number. So we want to do it in 2 steps. Any other questions on this here? Now again, we can't add or subtract -4 and 2 square root of 34 because of that square root. They're not like terms. But is there a greatest common factor with -4, 2 square root of 34, and 6? Is there a number that will go into all 3? Because -4 is divisible by 2. Is 2 square root of 34 divisible by 2? Well, you have the 2. And 6 is divisible by 2, yes? Now, there's 2 ways we can look at it. One is that we can factor a 2 out of the numerator, which would leave us with -2, plus or minus the square root of 34 over 6. I'm dividing each one of those by 2 and moving it out front. Now, what do we have here? We have 2 over 6, 2 divided by 6. What will 2 over 6 reduce to? 1/3. So the denominator is now 3, and the numerator is just -2, plus or minus the square root of 34. Now, another way we could have thought about this, doing the exact same thing, is that there is a common factor of 2 in all 3, and we could have just divided it out of each term. Because -4 divided by 2 is -2, plus or minus. 2 divided by 2 is 1, so we're just left with the square root of. And 6 divided by 2 is 3. The only reason we would do this here is if all 3 of those are divisible by whatever that number is. If we'd have had 3 here, if we had 3 here instead of 2, we can't really simplify it like this, because here 2, because this term and this term both were divisible by 2, and so was the denominator, then we can do it. Here we would have to split those 2 apart and reduce them individually, because they would reduce differently. Because 4 and 6 have a common factor of 2. 3 and 6 have a common factor of 3. Since they all 3 don't have the same one, we can't just simplify it together. But we wouldn't worry about that there. Any other questions on this here? How do y'all feel with these here? Because we'll do two more. Because the ones that I want to do are this next one here. So we are skipping a few because we should be at the back of the first page, letter C. Letter C on the note sheet. So if we want to solve this by the quadratic equation, the quadratic formula, not the equation, quadratic formula, we need the equation equal to what? We need this equation equal to 0. So what's the first thing we can do to get this equal to 0? We can add 4, which will tell me that the equation is 25x squared minus 8x plus 4 is equal to 12x. And then we would subtract 12x from both sides, telling us that 25x squared minus 20x plus 4 is equal to 0. Any questions on any of this here? You're welcome. Now we could have done this in either order because we could have subtracted 12x first, or we could have added 4 second, or done it this way here. Either way works out, we'll get the same thing. Because the main step to this is getting it equal to 0. Now again, the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now when I solve these here, there's two steps that I kind of do all at once when plugging in. And that first one is our negative b. Well, what is the value of b? Negative 20, yes? So negative, if b is negative 20, what's negative b going to be? Yeah. I mean, if b is negative 20, negative b would be positive 20. We're just changing the sign from positive to negative, or negative to positive. Plus or minus, square root. Well, b squared would be negative 20 squared minus 4 times a is 25, and c is 4. Everything inside the square root I don't normally touch. I'll just go on and copy it in, because I'm going to put it in the calculator, and the calculator will do it for me. The other thing that I will do as I'm plugging in is 2a. Because what is a? Value of a is? What's 25 times 2? It would be 50. Changing the sign with the b, negative b, or inputting it with that negative, I'll do when I plug it in, because that's not too bad, changing the sign. Or multiplying by 2. Both of those there are not too bad. We can do those as we plug it in. If you don't feel comfortable doing that, go on and write it out as negative, parentheses, negative 20, or 2 times 25. Go on and write it out. There's nothing wrong with that. Now, the next thing that we do need to do is simplify what's inside the radical. So we can type in the calculator, parentheses, negative 20, close parentheses, squared, minus 4 times 25 times 4. And if we type all that in, we get 0. We get 0. What is the square root of 0? 0, because 0 times 0 is 0. So we get x is equal to 20 plus or minus 0 divided by 50. Well, can I add 20 and 0 or subtract 20 and 0? Oh, yes. I mean, 20 plus 0 is 20. So we could do 20 plus 0 divided by 50. Or we could do 20 minus 0 divided by 50. Well, what is 20 plus 0? Well, 20 divided by 50, we would reduce 2 over 5. 20 minus 0 is 2. So the answer is 2/5. So we have 2 answers, but how many unique answers do we have? 1. Because both of the answers are what? 2/5. Are they unique from each other? No, so we only have 1 unique answer, but we do have 2 solutions. Questions on this here? Let's do one last one. This one here. Now again, we need this equal to what? 0, so we can subtract 13 from both sides, which will tell me that negative x squared plus 4x minus 13 is equal to 0. Now, the quadratic formula really doesn't care if a is negative or positive. Either one will work. Let's go on and start plugging in. So negative b, well, what is the value of b? 4. So negative b would be negative 4. Plus or minus the square root of 4 squared minus 4. Well, a is negative 1 and c is negative 13. All over 2a. Well, a we said was what? 2 times negative 1 is negative 2. Well, negative 4 is not going anywhere, negative 2 won't either. But we do need to simplify down what's inside the radical. So we need to take 4 squared minus 4 times negative 1 times negative 13. And if we do that, what do we get? What'd you get? Okay. Is it? Yes, sir. Because it would be negative 36 if we calculated this out. Now this one here is going to be one where we don't want to type the whole thing with the radical into the yellow calculator because it will give us an error because it can't take the square root of a negative number. So again, that's why I kept saying we want to simplify what's inside the radical first. Because for most of them, if it is a positive number, it's not going to make that big of a difference. But if it is a negative number, well, now I'm going to have to retype everything in there again and do the steps over twice. So we might as well just figure out what's inside first. now that we have that figured out, well, -4, -2, we can simplify the square root of -36. Well, we know the negative is going to come out as what? I. Because anytime we have a negative inside of a radical or inside a square root, it's going to come out as I. Which leaves us with what? The square root of 36, which is 6, because the negative came out as I, leaving us with the square root of 36, which is 6. That's why we do this, because if I have a negative inside that radical, the negative comes out as I. We can take the square root of whatever it is and get our answer. Any questions on this here before we finish this up? Because there is one last or two last steps. Now, we could go on and divide both of these terms by -2, and it would get us to the answer. I want to do another step in the mix here. Because if we said that 2 didn't divide into both of those, if we end up having said it was I square root of 7, which is not divisible by 2, we have to do something a little differently, because we cannot leave the denominator negative. We need it to be positive. We can't have a negative in the denominator and numerator. We don't like that. So what we end up doing is I factor it out of the denominator and apply it to the numerator. Factor it out and multiply it by the top, which is really just going to give us -1 times -4 plus or minus 6i. We do this here if it's not divisible by whatever the denominator is. Here it is. We could have just divided by -2 and got to the same answer. But if it's not, we're really just moving that out from the bottom and applying it straight to the top. I mean, we could do it the other way, pull it out of the top and apply it straight to the denominator, and it would do the same thing. Well, when I distribute the negative, -4 would be +4, yes? The negative applied to the plus, and the plus or minus would make it negative, yes? And the negative applied to the negative would make it +6i. Because with the plus or minus, the plus becomes negative and the negative becomes plus, which makes it still plus or minus. So multiplying plus or minus by a negative just makes it plus or minus. It stays the same, essentially. Now, we kind of noticed already, I have a feeling you all noticed that 4, 6, and 2 are all divisible by 2, yes? We can go on and divide it. 4 divided by 2 is plus or minus. We could have done that from the get-go and just divided it by the -2 and got to this here. But I wanted to show you this here just in case one of the two or both of the two numerators could not both divide by that denominator. Because if they can't, we still need to get rid of that negative from the denominator and move it to the top. Or if you'd have multiplied everything by -1 from the beginning, or gotten rid of, made a squared, or sorry, the a term positive, it would have never come up. Questions on this here? There is one last thing we are covering, and that is the discriminant. The discriminant is the b squared minus 4ac. There's three types of solutions that we can have. We can have where it is equal to 0. I'll get that later. Greater than 0 or less than 0. It's going to be one of these three that we can have. Now, b squared minus 4ac is greater than 0. What we're going to have is two real solutions. If it is equal to 0, we're going to have one real solution. Well, really, with the one real solution, we will have two actual solutions. They just won't be unique, like we saw earlier with the, I believe it was 2/5 and 2/5. Well, we got two answers, but really we just have one real solution. They're just not unique. And the last one is going to be what I call two complex solutions. Or they'll call them, the book will call them two imaginary solutions. We have imaginary numbers. We have complex numbers as our solution. So the discriminant will really tell us what kind of solutions we're going to get. And that's really the last thing we're going to cover. So when we look at this here, x squared minus 6x plus 10, we want to find the discriminant and tell how many solutions we will have, or what kind of solutions we will have. So here we're utilizing the b squared minus 4ac. Well, here b squared is -6. Minus 4, well, a is, and c is. Now at this point we could type this whole thing into the calculator and it would give us an answer. Now -6 squared is 36. Minus, well, 4 times 1 is 4, times 10 is 40, and 36 minus 40 is -4. So b squared minus 4ac is less than 0. So we would have what? 2 complex or imaginary solutions. And then from there, we could go and find out what the actual solutions are, what the answer is from there. But are there any questions on finding what the discriminant is and what kind of answers we will have? We're ready to look at the next one. So again, we're looking at the discriminant, b squared minus 4ac. Well, what is b squared? -6 minus 4 times 1 times 9. Well, -6 squared is still 36. Minus 4 times 1 is 4, and 4 times 9 is 36 minus 36 is 0. So the value of the discriminant is, what kind of solutions will we have? Real solution. And let's look at the last one, C. So b squared minus 4ac is the discriminant. Well, our value b would be, well, -6, so we have -6 squared minus 4 times a, which is still 1, and c is 8. Well, -6 squared is 36. 4 times 1 is 4, times 8 is 32. So 36 minus 32 is 4. So how many solutions would we have? 2 real Any questions on this here? Okay. Now, this isn't entirely what the question asks for, because it asks for one more part to it, and it asks for us to find the actual answers. On the test itself, I will ask for the discriminant and types of solutions. I'm looking for 4 two real solutions. Here, first, it says find the discriminant of the quadratic equation. Describe the number and types of solutions. So it wanted 4 two real solutions, and then it actually wants what they are. Well, we can still use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now for us here, the value of b is negative 6. So negative b would be 6 plus or minus. Well, we would have the square root of b squared minus 4ac, yes? What is the value of b squared minus 4ac? 4. We already found it. And a is 1, so 2 times 1 is 2. So for these problems here, since you already found b squared minus 4ac, you might as well just plug it in. You don't have to go back and re-find it. Now, what is the square root of 4? Is just 2, yes? Can I do 6 plus 2? Can we do 6 minus 2? Well, yeah. Since we can actually add and subtract these, we're going to have to add and subtract. We're going to have to simplify these down. Yep. 6 plus 2 is 8. And 8 divided by 2 is 4. Six minus 2 is, and 4 divided by 2 is. So really, there are 4 problems on the homework that are like this. It's going to ask for the discriminant, which for this here would be 4. Since it is positive 4, we would have 2 real solutions, and they are 2 and 4. And that is it. Are there any other questions on this here? Any questions on anything we've done so far today? And I have more of these here put in, and we're not worried about that. But that is it. We are officially done with chapter 3. Finally.